Hello. Yeah, I think we are live. Uh, okay, hello, children. Welcome to Spark Academy, and this is Anupama, physics lecturer, and today we are going to discuss about the important concepts of physics, especially EAMCET and NEET point of view. We will discuss what all are the important things here. Right. Just a minute. Let me start topics. I hope you all are able to see me. And yes, just give me a simple message so that I will. It will be clear for me that you all are listening. Right? Are you able to hear me? Okay. Uh, quickly, let us start this. Fine. Just give me a quickly message, children, so that I'll have an idea you're listening. Okay. Yes. So let us quickly come back to this now. Yeah, as I told you, this is Anupama, and we are going to discuss about the motion in a straight line. Right. So, in the motion in a straight line chapter, here in this chapter, we are going to learn about those objects or those things which are moving from one place to another place. Okay. Kinematics is the study of motion of a body. Okay, motion in a straight line, and we can also call this as kinematics, which is the study of motion of a body. Okay, so in the study of motion of a body, uh, in the study of motion of a body, we are going to learn about those physical quantities which are responsible for the motion of the body, like which describes the body's motion from one place to another place, right? So in this here, we have again two different types. One is horizontal motion, and the other one is vertical motion. Okay, coming to the horizontal motion, I think you know horizontal motion is nothing but a body moving from one place to another place or horizontally. Like all those bodies which are all those bodies which are actually in the straight line motion and moving horizontally. A perfect example is car moving on the road, and we all are moving on the road. These all are horizontal things. We move horizontally, isn't it? So this is the thing. And coming to the vertical motion, a body moving again in the straight line motion only, but body moving away from the earth, going up or falling down. Okay, means a body which is projected upwards or a body which is falling down freely. So all these things will be there in here in this lesson. And topic wise we will discuss what all other topics are there, but whatever are there, they are very very important exam point of view, like MCET or NEET, whatever it may be. I wrote here percentages also. This percentage is based on the last year's MCET and NEET question paper. And a 6% is almost two questions of the question paper, and it consists little more. Okay, so this is how the weightage is. Okay, and coming to the topic overview, here we have initially we will learn about the rest and motion of the body. Okay, and then as I told you, we are going to learn about distance, physical quantities which are actually which are responsible for the motion of the body. So these physical quantities we are going to learn here. And then what are the physical quantities? Here we have distance, displacement, velocity and acceleration, right? And also equations of motion we have, and obviously the vertical projection. Okay, so this is about the topics what we are going to learn here. Okay, now coming to this, I think you are viewing this page, the YouTube page, through the Spark Academy. Spark Academy, offers many different courses in MCET, NEET, JEE, and also this is means there's a facility we have here, both offline and online. You can just install the uh, Spark Academy app from the Play Store, and then start using it once you enroll for the particular particular groups or particular batches you want. Okay, so you can here see here, this is our the home page how we have here in the app. Like this particular page is showing us our app actually. Our app consists of free handwritten notes. You can just, that is for free. The study material is free. Once you enroll here, then the study material is free. And here we have free handwritten notes, free study materials, and we have even previous year's question papers also. And these question papers are solved question papers. Now you can just have it again. The free mock tests will you will have here. So this is the home page of the app actually. Once you enroll, all these facilities you will have in the app. Okay. So this is about the Spark Academy app. And coming to the motion in a straight line, as I already told you, here in this lesson, we are going to learn about those physical quantity which describes the motion of a body. Okay, like the very first and foremost, which is very very important here is, important physical quantity which describes the motion of the body is distance and displacement. I hope you know that difference between distance and displacement. Okay, what is the difference between distance and displacement? Distance is nothing but the total length covered by the body, and displacement is the shortest distance. Okay, displacement is the shortest distance. Okay, and what is the similarity here? Distance and displacement both are used for measuring the total length traveled by the body here. But the thing is, distance, no, it is irrespective of the direction. If we will take we will measure the total length covered by the body, whether it is east or west or any other direction. We don't consider all these. This is about distance. And coming to the displacement, displacement is the shortest distance, and here in the displacement we have a final point minus initial point of the body is called as the displacement. Like, we'll just see here. Displacement is the final minus initial point. Whereas distance is the total length covered by the body, right? That is how it will be. And uh, see, for example, whenever a body is starting from one point and again after so much of change in the positions, again it comes back to the same point, then displacement will be zero, whereas distance is the total length covered. So that we have to remember, whatever type of motion it is, whether it is, now we are discussing about the straight line motion, but even if you take any other type of motion, like the oscillatory motion, or the circulatory motion, whatever it may be, here what happens is displacement, if a body starts from a particular point and again comes back to the same point, time is not a criteria. If it comes back to the same point, then displacement is considered to be zero. Okay, so this is the difference. And distance is a scalar quantity. I hope you know the differences between scalars and vectors. Okay, whereas displacement is a vector quantity. So this is about distance and displacement. Okay, and next physical quantity which describes the motion of the body is velocity. Velocity. What is velocity? Displacement by time. Velocity, or you can also take this as speed. Velocity or speed is nothing but displacement. Velocity is displacement by time, and speed is distance by time. Okay. Velocity is also a vector quantity because it is depending upon a vector which is displacement, and speed is a scalar quantity because it is depending upon the distance covered. Okay, so this is the difference between velocity and speed. And what is the similarities in between velocity and speed? The similarities are, velocity is a velocity and speed both are measured in meters per second only, means they have same units. Okay, and the higher units of velocity and speed is kilometers per hour. Okay, because usually in the speedometers the higher speeds are measured, and the higher speeds are kilometers per hour. Okay, so this is about the velocity and speed. But we have here different types of velocities and speeds. What are the different types of velocity and speed? The first one is uniform velocity. When can you say that the body is in uniform velocity? When it covers equal displacements in equal intervals of time, then that is uniform velocity. And the speed is when it covers equal distances in equal intervals of time, that is the speed. Non-uniform, there are bodies which will move in non-uniform velocities also. Non-uniform velocities are those velocities in which the body travels unequal displacements in equal intervals of time. And speed, non-uniform speed is body traveling unequal distances in equal intervals of time. Okay, so this is about uniform velocity or so this is about non-uniform velocity or non-uniform speed, right? And we also have average velocity. Average velocity is very important examination point of view. Usually average velocity we consider when means usually immediately the term when it comes into our mind we think that it is the average of two velocities, right? Yes, absolutely it is correct. And average of two velocities when it will come when the body is traveling equal distances in equal intervals of time, then obviously average velocity can be measured by taking average of two velocities. But here what happens is this is not about that. We are discussing, for example, about we will try to solve these problems at the end of this session also, so that you will get an idea. See, for example, a body is traveling half of the distance in with a velocity v1 and another half with a velocity v2, for example. Then how can you write the average velocity here? Average velocity is equals to average velocity is equals to total distance by total time. That is x1 by x2 by t1 by t2. But here he didn't give t1 and t2. Then how can you find out t1 and t2? From the velocities itself you can find out. That is velocity is equals to we have displacement by time. From this time is equals to displacement by velocity you can write. So in the same way, if you put those displacements velocities there and put in this formula, then you get average velocity for two instances, two positions of the body is given by 2v1 v2 by v1 plus v2. This is the formula. Same way here, here he has given, you can see here 2v1 v2 by v1 plus v2. And then here if there are three things, like here we have taken x by 2 in v1 and v2. Now if you take x by 3 in v1, x by 3 in v2 and x by 3 in v3, like we have three different velocities and three different positions of the body, then in that case we get formula like this. Means after putting all that in the average velocity formula, then you get in this way. What is that? V is equals to 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. Okay, so this is about the average velocity, right? And apart from this we also have instantaneous velocity. Okay, what is that instantaneous velocity? Instantaneous velocity is the velocity. Instantaneous velocity is velocity of the body at a particular instant. Okay, see this instantaneous velocity is given by ds by dt. This is instantaneous velocity. This is ds by dt. Okay, so this is about instantaneous velocity. And this is about the velocity, right? Apart from all these, we also have acceleration. Okay, what is acceleration? Acceleration is actually related to velocity. Acceleration is rate of change of velocity is called as acceleration. Okay, a is equals to v minus u by t. When a body is moving with uniform velocity, we have discussed what is uniform velocity, right? When a body is moving with uniform velocity, then the uniform in the uniform velocity, when a body is moving with a uniform velocity, in the uniform velocity, velocity at every instant it is same, isn't it? So v is equals to u actually, or v1 v2 v3 are there. For example, v1 is equals to v2 is equals to v3. So velocities at every instance are same. So naturally, in the uniform velocity, whenever a body is moving with uniform velocity, acceleration is equals to 0. When a body is moving with uniform velocity, when a body is moving with non-uniform velocity, so obviously it will have acceleration, and it will have variable. It may have same acceleration or it may have variable acceleration too. Okay, a perfect example for the same acceleration, body moving with same acceleration, is acceleration due to gravity only, isn't it? Body always moves with the same g value. That anyways, we will discuss that in the later stages. So this is about the acceleration. Now we have come to acceleration. We have one more thing here, that is retardation. I hope you heard this term retardation. Retardation is nothing but the negative acceleration. When can the acceleration, why acceleration is negative here? Because usually what happens is, in all the cases, acceleration and velocity. For example, a body is moving from one place to another place, right? Then in all those cases, acceleration and velocities will be moving in same direction. Okay, so acceleration takes the direction of velocity only, velocity of the body, right? But if you apply the brakes, okay, for example, a body is moving from one place to another place and suddenly you apply the brakes. So we know that suddenly the body cannot stop. A vehicle cannot stop that suddenly. So slowly its velocity decreases, meaning the acceleration and the velocity will be in the opposite direction. That is the reason why we are getting acceleration negative in here in retardation. Okay, so this is about retardation, and this is about the acceleration. By taking these all the things, how many things we have learned here? We have learned about, like, to describe the motion of a body, how many things you should know here. We should know about velocity, we should know about acceleration, we should know about displacement, distance traveled by the body, in what time the distance it is covered, and all that, isn't it? So all these things we will come to know. All these things we will come to know actually. Only if all these things we know, then we can describe the motion of the body, whether it is moving or whether it is not moving, whether it is rest or whether it is in motion, isn't it? When all these things are changing, naturally we can say the body is in motion. When nothing is changing, the body is not changing its position with respect to surroundings, so no need to describe all these displacement, distances and all that, then body is said to be at rest, right? Naturally. So this is what it is. Now after learning all this, let us relate to know the motion of the body. Okay, so how can you relate this? Like by using the equations of motion. By using the equations of motion. How many equations of motion are there? Right. The first one we have is V is equals to U plus AT. I am just writing directly. And second one is S is equals to UT plus half AT square. And the third one is V square minus U square is equals to 2AS. Okay, V square minus U square is equals to 2AS. These are the three equations, and the fourth one is also there. That is a displacement in the nth second. This is equals to a by 2, I mean u plus a by 2 into 2n minus 1, right? So this is about the equations of motion, which actually describes the motion of a body. Okay. So from all these equations of motion, for example, the body is starting from rest. In all the cases, u is equals to 0, isn't it? In those cases where u is equals to 0, we have from this v is directly proportional to t, and we have from this t directly proportional to root s, v directly proportional to root s. These are all the relations from these equations if u is equals to 0. If u is equals to 0, these all are the relations you will get. Okay. So this is about the velocity of the body, I mean equations of motion, right? So yes, here we have again, I mean, yeah, let us come back to our app. Let me tell you again something about this again. Like we have what we have in the Spark store in the app. Like previous pages, we have seen the home page of the Spark app, isn't it? I told you there are free question papers, mock test papers, the previous year question papers, and all that, right? Apart from that, we also, what more we have in the store actually, we have a few courses which Spark Academy is offering, that is long term courses, crash courses, mock tests, previous year solutions. Already I told you this. And then full length tests we have, and free study materials. Once you enroll here, once you buy these courses, any of the courses, then you will get all free here, right? And yeah, we are open for the admission. You can just join now immediately. We have even hostel facilities also with the study hours. Okay, that is actually very very important. And we have offline, we have online. What are the offline here? Long term coaching from 10 to 4, and regular coaching from 6 to 9 in the evening, so that you can attend even other colleges. Those who are attending also can join our 6 to 9, because in many of the colleges in and around Hyderabad, they are not offering these long term short term courses. So you can as usual attend your colleges and come back here. Okay, 6 to 9, right? So we have that is about offline. We have even online coaching also. In the online coaching, we have NEET courses, JEE Mains batches we have, and EAMCET batches also we have. This there are 4 numbers which are visible here down. You can just call the numbers for more details, right? So what are the lives like, even if you miss by chance, if you miss any of the class during the hours, the live sessions, then in the app we have recorded videos, so that if the child is due to any reason, if the child is absent for that particular class, he can watch the video whenever he get time, so that he will not miss that particular topic. So we have this live sessions too, I mean recorded video session too. No particular app will have this, only except Spark Academy. So grab this opportunity, right? And yeah, we also have this. See here, uh, you can see the notes, the live videos you can see here, isn't it? And also assignments, you can see here we have assignments here, everyday assignments, online assignments, homeworks teachers will give. They will definitely tell in the class, but apart from that, if the app contains these assignments, parents can also check what's happening, which lesson teacher taught on that day, and what assignment teacher is doing, whether the child is submitted the assignment or not. All these things you can parents can have an eye on this, right? So like this, the assignments are for every batches, the assignments will be different. And here the test details there itself, like the analysis, the marks, everything you'll get here. Okay. Yeah, how we teach, like usually we teach starting with the basic concepts, and then shortcut methods. What are the shortcut methods we have? Like for this, it's best you enroll your names in our academy app, and also we have telegram, instagram groups also. You can just follow us so that you will get more details in that. So this is our methodology of method of teaching. Shortcut methods, model questions, exercise questions, chapter wise tests we will have, weekend test, grand test, and the analysis obviously. Okay. So this is about the Spark Academy, and now let us come back to the motion in a straight line. Okay, and we are discussing about the motion in a straight line, and we have stopped at the equations of motion, right? Apart from equations of motion, anyway, equations of motion will give you the connection between different physical quantities here, right? And it also tells us equations of motion also the very two important things here in equations of motion is it will give you the relation between the different physical quantities, first thing. And second thing is that whatever you are what all these are actually variables. The known variables will be there and unknown variables like displacement, velocity, initial velocity, final velocity, time, acceleration. All acceleration is not variable actually. All these equations of motion you will learn under uniform acceleration only. Okay. So apart from acceleration, because in all the equations of motion acceleration is common, apart from that remaining all are variables, and in those variables whatever unknown thing is there you can find out by using the equations of motion, right? So apart from equations of motion, the other thing which describes the motion of a body is graph. Okay, graphs also tells us that in for you there are actually three important graphs you have. One is yeah. The first one is a displacement time graph. Displacement time graph. What does displacement time graph tells? The slope of displacement time graph will give you velocity. One thing we have to remember here is one thing we have to remember here is in any of the graph here you can see always t is taken on x-axis and the remaining physical variable is taken on y-axis. Like for example in displacement time graph, time is on x-axis and displacement is on y-axis, right? So this particular thing tells that this is a line which is parallel to x-axis, shows that time is changing but displacement is not changing, which is nothing but the body is said to be at rest. Okay, and here you can see this one, like s is directly proportional to t, like uniform motion you can say. Okay, so this is also u is equals to 0 and s is equals to 0, and u is not equal to 0 and s is not equal to 0. So this is how the graphs helps us, right? Displacement time graphs. And next we have velocity time graph. Okay, velocity time graph will tell you about, slope of velocity time graph will give you acceleration, and area under velocity time graph will give you displacement. These things you have to remember. And depending upon the shape of the graph, you can say whether it is at rest, whether it is a motion, uniform motion, variable motion, retardation, or whatever it may be, right? So this is velocity time graph. And next we have acceleration time graph. In acceleration time graph, actually acceleration is equals to velocity by time. From this we can say velocity is equals to acceleration into time. That means acceleration time graph, area of acceleration time graph will give you velocity. So in among all these, time is taken on x-axis and velocity, that second variable is taken on y-axis, right? Yeah. Okay, so this is about horizontal motion. Even graphs are also useful even for vertical motion also. Okay, it's not that graphs are applicable only for horizontal motion. Graphs are applicable even for vertical motion, right? So now we have motion under gravity, which is actually a vertical motion, right? Here there are two different cases. One is body thrown upwards, the first one. And next one is freely falling body. Okay? Yeah. Body thrown upwards. This is body thrown upwards. Initially it will have velocity, but the final velocity is equal to 0, and as it is going, like usually what happens is here in vertical projection, acceleration is equal to g and the displacement is considered to be h, height, no, the body reach. Okay, so u and v is equal to 0. It will be final velocity is 0 and acceleration is equal to minus g. Why negative? Because it is going away from the earth's surface. Okay, and these are few cases, and this is the height reached by the body, and this particular thing is called as maximum height, where up to what level it can reach, that is called as maximum height. Now next is freely falling body. Freely falling body, initial velocity will be 0, but it will have final velocity. Okay, so and here acceleration is equal to g and this is h. From all these, if you put all these in the equations of motion, we get few formulas. We'll quickly discuss these formulas. Maximum height is equals to u square by 2g you will get. And velocity on reaching the ground, here v is equal to under root of 2gh you will get. This here time of ascent, because the body is going up and it is u by g. This is time of descent, it can be under root of 2h by g or u by g also you can write. Combinedly you will get time of flight, which is 2u by g. Okay, 2u by g. This is time of flight, right? So this is about a body thrown upwards and freely falling body, right? I hope this is clear. Now we will move on to the next thing, that is we have few problems here. We'll just discuss about few problems. Right. See here a body, this is the first, basic problem what we have. A body is moving along a circumference of the circle of radius, like I am drawing a circle, and this is radius r, body is moving in a circumference of circle of radius r and completes half of the revolution. Half means, for example, it is starting from A and it reaches B, then it is half, isn't it? Ratio of displacement and distances. Here, distance is always measured along the circumference and displacement is measured from final to initial. Final to initial is AB, right? I'll write here. Displacement is equals to AB, that is diameter of the circle. R plus R, this will be 2R, right? And what is the next one? We have distance. Distance is equals to, as I told you, half of the perimeter of the circumference, half of 2 pi r. This is pi r. Now what he is asking, ratio of displacement. Displacement is represented by S to distance, that is 2r by pi r. R gets cancels, so it will be 2:pi, the third option, right? So this is how we will do. This is the basic one we have, and next one, right? Next one here, if the distance between the sun and the earth is 1.5 into 10 power 11 meters and velocity of light is 3 into 10 power 8 meter per second, these are the initial stages of kinematics, initial problems of kinematics. In our next session, we will discuss about the very important questions which have come in the previous year question papers. Previous years like EAMCET and NEET, we will discuss those questions in our next session. Now, what he is asking is the time taken to reach the ground. He is asking. This is very simple. Velocity is equals to distance by time. That is 1.5 into 10 power 11 by 3 into 10 power 8. This is 3 1 ja 3.5, and this 10 power 8 goes up, it will be minus 8. So 11 minus 8 will be 3. So we get here 0.5 into 10 power 3 can be written as 500 seconds. We are calculating in terms of seconds here, right? 500 seconds, right? And next one. Yeah. If a body moves half of the distance, just divide. It is moving from A to B. Half is x by 2. Half of the distance with 10 kilometers, 10 kmph, and another half with 15 kmph. Then what is asking? Average speed. What is the formula we have here? 2v1 v2 by v1 plus v2. Let us suppose this is v1 and this is v2. You get 2 into 10 into 15 by 25. 2 2 ja 4, 4 3 ja 12 kmph. Right? So this is the thing. Yeah. Now, distance traveled by the body 2s is equals to 10t plus 5t square. They are asking us to find out acceleration. Okay. First, s is equals to, I can write 10t plus, this is plus, right? Plus 5t square by 2. Now, v is equals to ds by dt. 10 by 2 is 5, right? Isn't it? I can write d by dt of 5t plus d by dt of 2.5 t square. Right. So differentiation of 5t is 5 plus differentiation of 2.5 t square. Differentiation of t square is 2t. 2.5 into 2 is 5t. This is what we got as velocity. Now acceleration is equals to dv by dt. So differentiation of 5 is 0 anyways. 5t is 5. So this will be 5 meter per second square. Okay. So when you have to find, means he gave displacement, and from displacement we have to find out the acceleration. Means first we'll find out velocity and then we will find out the acceleration, right? So this is about the thing. Now next we have s is equals to 12t plus 3t square minus 2t cube. He is asking us to find out the velocity at the start. Start meaning t is equals to 0. Okay, fine. V is equals to ds by dt is equals to differentiation of 12t is 12 plus 3 into t square is 2t, that is 6t, minus 2 into differentiation of t cube is 3t square. So 6t square. Now put t is equals to 0 here. Here this becomes 0, this becomes 0. So velocity will be 12 meter per second. Okay. So this is about finding out the velocity. Finding out the velocity from displacement. How you did this? This we got. This we got by differentiating. Okay. So this is how we find out the velocity, right? So now as I told you, I hope this class is useful for you all. And I wish you get more and more doubts and ask us in the next live session the doubts which are related to the topics which we were teaching. And now coming, as I told you, we our Spark Academy also have Telegram. You can just use that link which is given here, which is displayed here, and join our Telegram group so that we can have the discussions about the question papers. We can have discussions about the important questions which are there in our previous sessions and all that, and the question paper weightage also, results, and the top engineering colleges, and the last year's engineering seats and all that, all the information. We can have a healthy discussion in the Telegram group. So join our Telegram group here and see, these are our results. The highest score we have here, it is growing, and last year we have a tremendous good amount, amazing amount of results here. So you can see 2019 5, this is actually the NEET score. 20 we have 15, and 2021 we have 19. Hope we have more and more this year, right? I hope this class is useful, and those who have not subscribed to our YouTube channel, you can subscribe Spark Academy YouTube channel for the free YouTube classes. And those who have not downloaded the Spark app, never too late. You can just take out your Play Store, go to Play Store and download the app and subscribe. Okay. Thank you, and we'll meet again in our next class.